Hello everyone, in this video I'll be going through some mastery checks for 2D and 3D kinematics, 2D K2, number 3, and number 2. So here's the first problem we'll be working on. So it says a particle has a velocity of negative 1.3 I hat plus zero point 0.1 j hat meters per second when it is at 2.9, 2,9 meters the xy plane when it begins accelerating at 5.5 I hat plus 3.7 j hat. So these are all initial values that it's given us. So what we gotta do is just find what the x-coordinate is when it's at 4.6 seconds, y-coordinate when it's at 4.6 seconds, x-component of the particle's velocity at 4.6 seconds, the y-component of the particle's velocity when it's at 4.6 seconds. So to first find the x-coordinate, we're looking for position. So we do know many initial values. So we know the initial velocity in the x direction is negative 1.3 meters a second. We know the acceleration in initially is 5.5 meters per second squared in the x direction. And the initial position is 2 in the x direction. Using this, we can use the formula delta x equals 1/2 a t squared plus vi x t to find the value in the change of x. So let's plug in our values here. 5.5, t is 4.6, because that's the value we're looking for. And then 1.3, 4.6. I would write units, but I'm trying to make this pretty fast. So if you plug that into your calculator, you should get this value, 52.21. That's the delta x. So delta x is x final minus x initial. So this is our x initial. So if we have the delta x and we have the x initial, we can find the final position by adding 52.21 delta x by 2, which gives us 54.21 meters. So, as you can see, that is the correct answer for this part. Now, the same thing can be said for the y-coordinate, so we're just going to skip that and go on to the x part for c. So, we can say that the initial velocity, actually we have all the terms down here. So let's look back at these values. So it's asking for the velocity at 4.6 seconds. So we're looking for a final velocity. So we know that final velocity equals acceleration plus vi. Acceleration times time plus initial velocity. This can be said in the x direction. So let's plug our values in and see what we get. We should get 24 meters a second, which is, as you can see, the answer to that problem. So now let's move on to question number 2, which I'll have to get. Okay. So it says a ball is thrown horizontally at a height of 9 meters above the ground with a speed of 26.6 meters per second. So thrown from a height 26.6. No, wait, my bad. I read it wrong. 9 meters is for the horizontally, which means it has no initial y, it's just initial x. So, and we're trying to find all these questions. So, let's do that. So, how long is the ball in the air? So, what do we know? We know the initial velocity, the x direction. We know the acceleration, which is gravity, or 9.8 meters per second squared. Let's just say down is the negative direction in this case. And the speed, so we know delta x, which is 9 meters. So is going down 9 meters, so negative 9 meters. So let's use the formula for all the values that we have. So we can find time by rearranging everything into the quadratic formula, because this is equal to 0. And as you can see, this is a quadratic. So let us plug in everything. So we know neg 0.5 or 1/2 times gravity, 9.8 meters per second squared, negative 4.9 t squared plus initial velocity, which is 26.6 t, minus a negative value, so it'd be plus 9 meters. And if you just do the quadratic equation, which I'm sure you guys all know how to do, you'll get that time equals 1.355 seconds. After getting this, that's when the ball hits the ground, so it takes 1.355 seconds to get to this point where it hits the ground. So to find the horizontal displacement, we just multiply the time by the constant x velocity, which will give us, so pretty much what it's trying to say is delta x equals vt, 1v is constant. So plug the values in, get that delta x equals 36.043. How fast is the ball traveling when it hits the ground? So we know the x velocity, but we don't know the y velocity. The y velocity is going to change because of gravity. So we do velocity final equals at plus velocity initial, the y direction, and we just plug in values. So 9.8 meters per second squared times t, which is 1.33 or 35, which we don't know this. And you should get something like the velocity final y is equal to 13.279. So if we know the velocity in the y direction, the velocity in the x direction, we can find using Pythagorean Theorem, as this is a triangle. The ball is making contact, moving at two vectors of 13.279 and 26.6, so tangent of theta equals y component. Oh wait, I skipped to the third question, my bad. So you just do the Pythagorean theorem, 13.279 squared plus 26.6 squared equals 29.73 meters per second. So that's the final velocity when it hits the ground. So you can see that is the answer. And now we have to find the angle. So we're pretty much just going to do what I just said, tangent of theta. So if we were trying to find this angle, equal to y component, divided by the x component. And you just do inverse tangent of this value, and you get theta. So yeah, that value should be 26.57. Now let's move on to the third question before the video gets too long. This one's pretty quick. Okay, so pretty much this question is saying launch speed is 4.2 times its speed at its maximum height. So VI is equal to VIX, because maximum height, the velocity in the y direction is 0, so x velocity times 4.2. But what is VIX? VIX is equal to cosine theta of VI. So if we convert this into this and continue the equation, we can divide both sides by VI. So that gives us 1 equals cosine theta times 4.2. Now all we gotta do is divide, so we get cosine theta on one side, and then do inverse. That should give you 76.22 degrees, which is the angle that it is launched at. Now let's move on. Particle starts from the origin. Okay, so it's very similar question to the first one. I'm sure you guys can figure it out. So this one's actually pretty tough. Let's do this one real quick. So pretty much says two projectiles are launched from the same height of 22 meters above with a speed of 21.5 meters per second. One is launched at 51 above and one is launched at 51 below. So if you were to draw an image, I'd say like, here's 22 meters. It's launched from the top. One of them is being launched downwards at an angle of 51. One of them is being launched forwards at an angle of 51. And it's all both traveling at an initial speed of 21.5 meters per second. We can do cosine times velocity initial of the angle, which is 51, to find the values of both x and y components. So let's call this angle 1. And I'm going to call this one angle 2, just to like help clarify. So the velocity in the x direction for both of them is going to be 21.5 cosine of theta, which is 51. So it's going to be 13.53 for both. Whereas velocity initial in the y direction is going to be the sine value, but we're going to have a negative angle. So for angle 1 right here, it's going to be 16.7 meters per second in the y direction. But for angle 2, is going to be negative 16.7 meters per second. So now we have all the information we need to find how far the ball travels, or the projectiles. So again, using the change in distance formula, well, this is supposed to be a y. So using this formula, we can solve for t. So using quadratics, you can just find for t. It shouldn't be too hard, but if you guys would like more information, y'all can comment, I guess, if I turn that on. So Your time, you should get something around 1.01 second for when it's aiming up. I mean, when it's aiming down, and when it's aiming up, you should get 4.423 seconds. So this one's for angle 1, this one's for angle 2, the time it takes to hit the ground. So we just find the change in displacement by multiplying this by the x velocity. So x velocity was 13.53 meters per second times 1.01 second equals 13.66 meters traveled for the first ball, which is aiming down. Then we do the same thing, except this value changes and becomes a 4.423. That will get us 59.84 meters. So if we just subtract these two values, so the one that went further by the one that was closer, we get 46.18 meters, which is the distance between the two landing areas. And what do you know? That is the correct answer. It's a little off because of rounding and such, but it should be correct. So yeah, thank you so much for watching. Have a good day.